Hello dudes, welcome to my channel. Hope you are all doing good. And I'm posting this video on 23/10/2022. And happy Diwali to all my subscribers and friends and all. So what we can see in this video, the control valve assembly and how to model it in E3D. So we can start the session. Now, what is control valve assembly? Control valve is the power operated device used to regulate or manipulate the flow of fluids such as gas, water, oil, and steam. It can be either operated electrically, pneumatically, and hydraulically. Control valve receives a signal from the controller such as PLC in order for it to move, resulting change in flow. So in this picture you can see there is one system, there is one assembly. You can see in 3D models everywhere in the plant, oil and gas plants and power plants like this. So why we are using this control valve assembly? So now we can see the upstream and the downstream. In generally, what is called upstream in oil and gas? Upstream is like oil companies are involved primarily with oil discovery, extractions, and productions. Now, what is discovery, extraction in FPSO and offshores, rigs, also wellheads, that is called as the discovery area, where the crude oil is discovered from there. And what is downstream? Downstream, the companies deal with the refining and delivering the petroleum products to the consumer. That is we called as refining, gas plants, refineries, and power plants, etc., etc. Sorry, it is not included in power plant. In oil and gas refineries like that, we called it as downstream. Now, in this picture, what is upstream? Upstream is the fluid coming from the source area for process, and downstream the fluid going to the process area. Okay, now what is bypass valve? Bypass valve, why we are giving the bypass valve, and what is the bypass valve we used in the control valve assembly. Okay, we can see this one. Now the fluid is moving towards the isolation valve. What is isolation valve? Isolation valve is nothing but the gate or ball valve. Okay, we can use gate or ball valve. The fluid is going through this elbow, and the drain is there. That will be the 3 by 4 20 mm, and there is one eccentric reducer. The flat side should be down, and also one control valve is there. Again, the fluid is going to the downstream area. Okay, there is some pressure gauge assemblies and the wall isolation valve, that is gate and ball valve. So bypass valve, we can use the globe valve as a bypass valve, and there is some procedures, there is some criteria we should follow while we are designing in the 3D models. Okay, now we can I will show you in paint. So so I can make it like this. Okay, now I can make one FGL. I can make FGL, that is floor ground level. Okay, in this I can make control valve assembly here. So here like this, it will be the upstream. Okay, dudes, we can see here control valve assembly. Control valve assembly. Here we can see. Okay, now so we have to make model in E3D. Before that, I can explain you here for the better understanding. So the flow is coming, that we call it as upstream. Now it is moving down, it's moving down, and just I can draw roughly. Okay, so the flow is, sorry, flow is going like this. Okay, now there is one gate wall. Sorry, before that there is one bypass line. So we have to draw from here the bypass line. Okay, and one wall is there. I can mention the wall symbol like this. Just understand this. This will be the wall symbol. This will be the bypass line, and the bypass line, the globe wall should be near to this T area. Okay, not center. It should be maximum near, maybe within 100 or 200 mm. It will be better. This is as per the procedure. Now we can see here, after the elbow there should be one isolation wall, that will be the gate or bar wall. Okay, after that one drain is there, with isolation wall. Then we have to close with the blind flange. To close with the blind flange. Okay, then there is one reducer, that is eccentric reducer. So I will keep the eccentric reducer, I will keep like this. One eccentric reducer is there. Okay, then one control wall is there. This will be the control wall. Again one eccentric reducer is there here. Then one tapping is there, that is the drain with wall. With blind flange. Again one isolation wall is there. So here isolation wall. Okay, the wall tapping, the drain tapping will be 3/4. Okay, now we can see this will be the bypass line. Bypass line. Bypass line. Bypass line. Why we are using bypass line means, when there is problem in the control wall, so we have to, we should not make any shutdown. Okay, we should not stop the plant. So what we will do, we will remove this control wall for the maintenance. Now then that time we can close this two isolation wall, gate wall or bar wall, for on and off purpose. Okay, then we close this wall, then we remove this spot for the maintenance. At that time we can use this bypass wall. Okay, and what is the size of the bypass wall? As per the, procedure, the size of the bypass wall should be is equal to the size of the control wall. For example, if the control wall is 100 mm, the bypass wall should be 100 mm. Okay, so the bypass wall should be near to this area, not center. Okay, then we can make this will be the gate or ball wall. Okay, what is the size of the tapping? This tapping will be 3 by 4, that is 20 mm. 3 by 4. Okay, and what is the reducer, eccentric reducer? It will be the eccentric reducer flat side down, FDST. Okay, why we are making this eccentric reducer flat side down means to maintain the BOP. What is BOP? BOP is nothing but the bottom of pipe. For example, if you are making the FSC means the bottom of the pipe is will be the same or equal. If you are making flat side up means it will change the elevation, the coordination will change. So for that purpose we are keeping this reducer in FST. Okay, now this will be the control wall assembly. There are many types of control wall assembly. What is that we can see here? So this is this is control wall assembly. So we can make, this is the control valve assembly. Flow control valve, it will be the flow control valve. Okay, FCV, and there is other more types also. PCV, that is pressure control valve, and LCV, that is level control valve, and TCV, that is temperature control valve. As per the requirements we use these control valves. And again it will be the eccentric reducer, and there is one tapping drain, that will be the 20 mm 3 by 4, 3 by 4 inches. And after that there is one isolation wall is there. This is the isolation wall. This is the isolation wall. Isolation, maybe gate or ball wall. And again one isolation wall is there, and this flow is going to the downstream area. Okay, now this is the procedure we have to keep, uh, in mind while we are making 3D models. Now what is the distance between the bypass line and the control valve? The distance between the bypass line and control valve is minimum 300 mm. We have to maintain minimum 300 mm. Okay, for the valve operation 300 mm we have to make 300 mm. And we have to keep some clearance for FGL to the drain operation. It will be the minimum 300 mm we have to maintain. Sorry, minimum 150 mm we have to maintain. Okay, now regarding up to 4 inches we are making a 100 mm for the weld gap. Weld gap 100 mm we are making for to 4 inches. Above 4 inches weld gap, should be 1D. So if it is 6 inches means 6 into 1 into 6, like that. 6 means how much? 150 mm. If it is 8 inches means 200 mm. So like that we have to keep the weld gap. Okay, now we can start. We covered all basic things in for the control valve assembly. Now next we will move to the 3D models. Okay, so I will open the E3D. Here I will open remove all. So I can drag any one side here. Just I can add this side. Okay, so what I do, I will remove this piping. Remove C. C means current element. Also I will remove this one. Remove C, current element. Okay, so for the better understanding I will keep this two vessels, horizontal vessels in opposite position. So I will rotate. What I do is north, apply. When I click C, put south, apply. Okay, so I will move this one east. Here you see, here east is here. So if you want to move here means you have to put E. If you want to move here means you have to put W. Okay, if you want to move there means you have to put N. You have to move in south means you have to put here. So this is you have to make like this. Okay, I will keep by east 5000, again 5000. Okay, so again 5000. So here, so what we do, we can start one model. Here for that we need to check the size of the nozzle. What is the size of the nozzle? So click here and click right clear. How to check the size of the nozzle? So if you click like this means it will select all the equipment. So what you do is just zoom and click right, and this symbol is there, navigation, click this one. So here what you want to select, vessel or nozzle? If you need to select the nozzle means click nozzle. So it is selected. This is the easiest way to select the particular elements. Okay, so what you do, what is the command is q para 150 mm. This is 150 mm, and also we can check this also. So again click here, go to the symbol nozzle, q para. So, okay, now the both okay, what we do is I have to create one piping. So I just click this side. I'm going to piping, create piping. Here I write control valve assembly. This is just for example, valve assembly. In E3D model, you should not give the space. It will not accept the space. Okay, control valve assembly. So I click any spec 150, and what is the bore we saw is 150. I click 150. So insulation tracing everything I put nothing. Okay, I click apply. Sorry, I didn't select the hierarchy. Okay, click this hierarchy. There is two zone, piping and equipment. So click this piping zone and go to this pipe. Here you write control valve assembly. Then in spec I can select game 150, and the bore will be the 150. Then apply. Okay, now you have to select the head and tail. In previous video I explained what is head and what is tail, and forward and backward everything. So here branch head is there, branch tail is there. So I click branch head. Here the arrow cursor is there. big head. So you have to click this arrow and zoom it here and just click this nozzle. Okay, you see here head is connected. And what is tail? Go to branch tail. Here you can click this cursor, click this one. Okay, head and tail is connected. So here you can see I can click this one. So what we have to do, I will show it in the command method. It will be the very easiest method. Okay, I just close this one, clear this one. And before making any models, you have to see the hierarchy, because this is the very important thing. If you keep in any other hierarchy and you started model, means it will make big error in future. Okay, it will be problem for you and others. So before making, you have to be on hierarchy, always check the hierarchy. So I created control valve assembly. I click this pipe and again I click this branch. Okay, then I start model. So what I do, by command method, I will show you. New gasket, I create new gasket. To all, F connect, just enter. Branch P point undefined. Okay, so it is not connected, I think. Okay, I again create on flange new. So it is not connected, so I delete this gasket. I will show you background PDMS background method. Enter. Head is there, nozzle is there, apply. Okay, this apply, identify nozzle means zoom this one, apply this one. Okay, now you can create, put this here, new gasket. To all, if connect, gasket is created. Now just double click here, remove this gasket, right flange, new flange to all apparent. This is the command to make the model very fast. Okay, just click here. Well neck flange is there. I click well neck 150 rating. Just okay. Okay, flange created. Now I have to create the elbow. So what we do? Just make this big. Again double click. Remove this flange. Make elbow. Enter. So I have to make 90-degree elbow. Okay, direction will be D. Downside direction D. Put direction D. And the spool will be, just put 100 mm, around 50 mm. Okay, again what I have to do, here you can see. So we can make up to here. After that we need to make one T. Okay, so what is the size of the T? So I will make this 100. Also this control valve will be 100. The control valve size and the bypass line size should be same. Okay, so what I will do is new T to all F connect. So I make 100. Okay, I will make 100 RT. It's 100. So I make the spool will be 300. Okay, again I want to make what I want to make. Again I want to make one elbow, control wall, sorry, gate wall, and one drain is there. Okay, so I will make it very fast. You see now already we have elbow. Just click and enter. Put 90-degree elbow. Okay, and what the direction is, it is facing in the north, so I will make it in direction east. So clear 300. I will make 400. Okay, 400. Then what I have to do, I want to make one get wall. So what I will do, I need to make one flange, left flange. So it is coming like that. So nothing, no need to flip over it. Filia 100, and I want to make cascade. So we make a gasket. Again, I want to make the wall. I click here, wall, VLV wall, enter. I make get wall here. So again, I want to make gasket. Again, I want to make flange. Okay, it will be the neck flange. Then I want to make a new wallet. Wallet, enter. So there is no wallet is not available in this pic, I think. Okay, I will click this one. So nothing, no issue. I will go to show cd comp. Open this command. Here I will make wallet. Wallet is not available in this spec, so it is not issue. So I can make it T. I can check this T. New T. Enter. You can see here TOL is there. Thread wallet is there. So for just for the example, I will show you. Just click thread wallet, and I want to make it 180 degree. Here 180 degree. So it is coming here. What I said for weld gap uh, up to 4 inches. We have to make 100 mm. Okay, what I do is I will make clear 100, and again I want to make one reducer. Okay, here you see this tapping we can make in last. So I want to make one eccentric reducer. What I do, and click here, I put reducer, create. So what we do, this is 100 mm, so I will make it 80 mm. Okay, eccentric reducer. Eccentric reducer, yeah, 100 I will make. So I can make 200. Okay, or 300. I can make 300. So again I want to make flange, neck flange. Again I want to make cascade. The cascade is there. Click enter. So I want to make one valve is there. Just click control valve assembly. So what I just put just get valve. Okay, this is control valve is not available, so just I put get valve. Just okay. And I want to make gasket. Double click enter. Double click enter on flange, enter. Build flange. Okay, so you have to make the reducer, eccentric reducer. Redo. Just go here, click create. This is the 4 inch. So what I do, 100 mm. No, this is not 4 inch. This is 6 inch. Okay, delete. Just click here, reducer, 6 inches, eccentric reducer. So I make 300 mm. So again I want to make the wallet new T. Here I can make 20 mm will it will be. So I rotate in 180 degree. So here also we can make 300 mm spool. Okay, then what I do, I want to keep one gate wall. Here I can go flange, well neck flange, 150 mm plus. So I make 100 mm. Then gasket, then wall. This will be the gate wall. Again gasket, again flange, well neck flange. Then what we do, then what we do, I want to make one elbow. Here elbow is there, 90-degree elbow. Click here, direction U. Okay, the distance will be 100 mm. I put 300 mm, 200 mm. Okay, so we keep two supports here also. One trunnion support will come here. Okay, that will be for the considerations. So here, what is the size of the wall? Just check Q para 80 mm. Okay, so I want to keep 80 mm. Here I put 100 mm. Okay, that is the mistake. I will correct now. So what I do, T, new T, 80 mm. Okay, so what I do, throw ID at the center with this one, and again you want to make one elbow. Just click enter, direction will be east, the center, and again so it will match this nozzle. So what I do, throw ID at enter, zoom this nozzle, just click. Okay, just click on this one, and I want to connect the tail. What I do, I will go to tail, nozzle, apply, and zoom this nozzle, just click. Okay, it is connected. So what I will do, I will click this elbow, then I want to make flange. Okay, click here, and again I want to make gasket. Just click here and go to, so I want to connect this flange here, so just click back, enter, be on this gasket, just connect, enter, and the next connect. See, it is connected here. Okay, so just save the work. So this is all connected. Just close this one. Okay, now I will make some changes in orientation for the valve operation for the easiest uh, way to operate the valves. So I can just click here and make 90. This also I click here, make it 90. So also click here or make it 90. Okay, sorry, 90, 180. Okay, now I want to just click this to all. For any modification, just click this component and make enter to all command and make it 80. You see it is 80 is there. So what I do, I want to create one more branch. Okay, just beyond this pipe, I need to create one more branch here. So what I will do, I will make a new branch. Enter. What I do, I want to make head and tail. Just enter. It will be the T. Okay, this component is T. So I want to change here T. Apply, click, and the tail will be the T. Apply, click. Disconnected. Okay. Now what I do, I want to make one globe wall for bypass lane. So I just click here wall. Now when you are modeling in E3D, it is, if you are using command methods, it is very easy. So before that, what you have to, okay, just go to the flange. See why it is coming like this. Why this is the head, this is the tail. Why it is coming here? Which means we put here back. Okay, so we want to make forward. Backward means the component will create here. Forward means it will create here. So I put forward. Now I will create flange, flange. See here, it comes here now. So yeah, it will be maximum. It will be the nearest to this mainstream. Okay, not in the center. So make it very nearest. We'll make gasket. Then I will make wall. Just I will click enter. It will be the global. So again I will make gasket, enter, and flange, enter. It will be the flange. Okay, so save the work. Okay, the distance should be minimum 300 mm. So change this wall orientation. We will keep it here 90, 180. Okay, now you can keep this wall also like this. Also you can make it 45 like this. Also you can make for the better wall operation. You can make it like this also. This 45. Okay, just save the work. Okay, dudes. Hope you are all understanding this one. When you are making this control wall assembly, you have to check everything, the space availability. You see here it is clashing. See, it is not possible for the wall operation. It is possible, but there is a little disturbance. So what you will do, keep this one in 90 only. 45, 90, 180. Keep this one in 90 only. Okay, it will not disturb the globe wall. Like this you can make. Also the distance should be minimum 300 mm, so we can measure it in distance. We can measure, you can see here this center. Here you can see 785 mm. It is too far, so minimum should be 300 mm. Okay, so what you will do, you can drag this one. Okay, you can drag this one. So click this wall, close this window, drag by D 300 mm. So click this D, drag by D 300 mm. See, it is moving. Okay, like that also we can make. Okay, mm, should be like this, and 45, 90. Okay, save your work. Okay, friends, hope you are all understanding this video. Now, what we have remaining. So this flow is coming from here and it is going to the downstream area. Okay, this is we call as control assembly. We have remaining this two tapping. Okay, two drains. So we can model it now. Just be on this one. You can make new branch. Just click. What you have to do, new branch. Then you have to make the component. You have to make the head and tail connection. What we can do, just double click this one, enter. Here head will be the T. We put in T, just click here. Okay, so we can make the component now. Here connect comp, connect comp. Just double click, enter. You can make a nipple fixed tube length. It will be the 100 mm. Just click here. So 100 mm. So again you want to make flange, create. One flange is there. You have to make gasket and you have to make a wall. So to make wall, it should be the get wall. Just click here. Okay, and you have to make again gasket. Okay, you have to make again flange, FP. So when resume, just make gasket. Okay, then we have to close this one here. What we do, we can make plain flange. So make flange. Here you can see there is no component available in the blind flange. So no issue, I can make it here. Then I will close here. Here last member apply. Okay, just clicking here. So I deleted this drain because I make one blind flanges by mistake. So I will model it again. So what I do, I will just click here. Will make a new branch. New branch. I want to create here. Just click here and what is the command? Connect BR. Here you can see the center. Head will be the T. We make it in T only and apply. Click. Okay. Now what we do, can make one nipple here. So pixel length tube. I can make it here. Create. A. Just click here. And what I do, I want to make flange. Just click here. Create. It is blind flange, so flanges is not available. What I do, just click here. So just I will just show you here. Okay, then gasket. Okay, then wall. I want to make wall. I make get valve here like that. Okay, then again gasket. Okay, then again flange. So I want to close it here. So again I want to make gasket and again flange. Again flange. I will make plain flange. Okay, click OK. So I want to end this line here. What I do, I will put tail, then I will go to the last member and apply. Okay, now you can see here it is connected like that. So the distance from this blind to the FGL floor ground level should be minimum 150 mm. Okay, so while we are modeling, we have to check all those things. Okay, so what I do, I will just keep this one. I'm not making again the 3D model. I just show you how to copy paste. Okay, just here make copy, here just paste, click this one. So measure here distance. I'll keep here graphics, graphics midpoint, just here like that. Also, sorry, not just here like this. So it is showing the east is 1247. The distance is 1247. So I click this branch. I am just moving, okay, by east 1247. See, it is coming here. Just save the work. Now in isometric it will not show. So we want to connect it here, okay. So what I do, I just click CE current element, be on this branch. Just click CE head. Head will be the T. Sorry, head will be the T. Just apply. Click this one, and the tail will be the last member. Just last member, apply. Now save the work. Okay, now close all these windows. Now you can see this is the control valve assembly. So if you have any doubt, you can comment in the comment section. Hope you are all understanding this video. And if you need any topics or any particular things you want to make model, you need to know, means just comment me in the comment box. I will make in the future videos. Okay, okay, okay dudes, thank you so much for watching. Please subscribe and share in your friends group. uh, just support for me. Okay, thank you friends.